Now this code looks a lot more cleaner. Now this is a virtual function. And if you were to notice, it's not called CPP actor, it's called a CPP actor. Basically, every actor is prefixed with an A and the actor class itself as well. Alright, now that we have established a basic understanding on creating a blueprint equivalent actors and objects, let's look at the inheritance hierarchy in Unreal in a little more detail. Now, I'm not covering everything over here. Now, I have left a few things such as interfaces, and I'm not going into each class. I'm just talking about the ones that you'll use in almost every project. So that should cover things for you. If you need anything in specific, the documentation should help you if you understand this much. So at the base level, you have UObject. Of course, you have your typical basic C++ class, but we are not getting into that. Now under that, I can categorize these into three main other classes which you'll use. Now there are many others, but you won't really use them. The first one, and which you probably expected, is a actor. Now an actor, or a actor as it's called in C++, is something which can be placed in the scene. So if you want to place something in the scene and write the code in C++, you would create an a actor, or in the menu or in the Unreal editor, it's referred to as actor everywhere. Now similar to pawn, you have a pawn, which is basically something which can be possessed by a controller. So basically you can control it, and it need not be you, it could be an AI as well. So maybe you could write some code for bots or something. So you would use pawn in that case. And if you have something specific like a humanoid character or something, generally for most of the things which will be pawn, you generally use character. So if you need a movement component and stuff like that, you would use character. Some functionality is already set up in your character, which is not set up in pawn. So something such as adding your controller pitch and yaw input, and many other functions which we will talk about as we use them. So that's where you'll use character. This might be clear. Now a controller is basically an actor which takes in input. Now you cannot place a controller in a level. Obviously, it sounds a bit stupid to place a controller in a level, but basically each player will have his own controller, and to be specific, he will have a player controller. If it's an AI or something, you have something known as an AI controller, but again, we are not getting into that. It's really not that common to use it. A controller will basically take your input. Now, although you can set up your input bindings in other actor blueprints, controller is the right one to actually hardcode bindings and stuff like that. Generally, when you create widgets which are not associated with your character, you'd create them inside your player controller blueprint. Generally, you create a player controller, you don't create a controller. And that's about it for what you'll use for the most part. And if we actually head into more gameplay oriented classes, you have a-info. The reason I put this is because this was just a wrapper for these classes which you'll use. You'll never create an a-info actor, so ignore this. This is just for your reference. Over here you'd see a game mode base. As the name suggests, game mode base, it's basically your game mode. So any code logic regarding your game mode will be there in this, and obviously it's really simple for me to just tell it like this, but once I take a couple of examples, it's going to be crystal clear for you guys. And there is also an a game mode class which is inherited from this, and it has some additional functionality. For the most part, we will stick with a game mode base, but again, you can feel free to use a game mode. Similarly, a game state base and a game state. Now you might ask, what's the difference between these two? The main difference is that game mode exists only on the server in multiplayer games, whereas game state exists both on the server and client. So things like match timers, which you would want all the players to be able to see as well, you'd have them stored in the game state. and maybe some other variables which you only want to use as a means of calculating something in game. So stuff which will only be there on the server in multiplayer games, or something which is core to your fundamental gameplay. So something like maybe, switching to another level when you enter a place or something. I mean, it depends on the game, honestly. Can't just tell what you do with it just like that. But basically, game mode, game state work together hand in hand. Now there's one more actually called the player state. Now the player state is really special because this is replicated by default to all the clients in multiplayer. We'll talk more in detail about multiplayer later on, but for now, just know that player state is going to be kind of the class which you'll use for anything that all the players must know at all points of time. And generally you'd store info common to a given player which other players need to know. Stuff like your player name would be there in your player state because all other players need to be able to access your player name at any point of time. So I just gave you an example. You could be creative with it and do whatever you want. Now one thing you might have noticed over here for the last one which I'll talk about under UObject is, or actually two more. Game instance is, as the name suggests, your game's instance. So this is talking about your game as a whole and not anything inside the game. So instead of begin play, actually you have something known as event init here. So let's say you call something off of event init, that actually runs well before your level actually loads. So we'll look into examples again. If you have anything pertaining to the game which has to sustain between level transitions, let's say you move from your main menu to your actual gameplay level. If you want stuff to sustain between them, let's say you wanted a variable to sustain, in that case you'd use the game instance because the game instance will not be destroyed between levels. But when you transition from one level to the other, all the actors and all the widgets, everything else that you could possibly think of are going to be destroyed. Now, speaking of widgets, we have multiple classes here which you'll probably never even touch. Even widget, to be honest, you'll never touch in C++. It's very rare that you'd require a C++ class for a widget. So user widget is the class which you'll use. Of course, in the editor, it's going to be referred to as user widget. So this is how you'd create widgets, but honestly it's too much of a pain to work with widgets in C++ for something that's just, very simple. You could just work with other blueprints and just have a blueprint widget which you'd interact with, stuff like that. So that's about it actually. Now the way you'd practically use this is you'd have one C++ base class. So for example, we can have, for a character, we can have one character and we can go ahead and derive one. So let's say we call this one R character. So let's say it is A, we'll just call it CPP as a convention, A CPP underscore R character. I'll just call it R char for now. Now what you do is you'd have core functionality written inside this class. So for example, your movement maybe if you have a first person shooter game, your firing logic, basically stuff that is mission critical for the game and stuff which would break if they don't execute. So for that you'd write it in C++. But other cosmetic things which you don't really require, and it's fine if it executes a bit late, stuff like, creating widget, maybe let's say you have a crosshair on the screen, maybe updating its position, if you have a dynamic crosshair that is. Or maybe, stuff which is not essential, like effects, spawning effects. So if you have stuff like that, which is not really mission critical, it's fine if it's a bit slow. And maybe if you don't have too many loops. So if you have many loops in your code, Blueprint generally runs slower. I will talk about why that is and stuff. So what you do is you'd have the core functionality in your base class, and then you'd create a blueprint class which I'm marking in yellow, and you'll call this one BP underscore rchar. Now this is just a convention I use. You could call it anything. You could simply call this one rchar. So this is going to be our blueprint class, and this is what you'll spawn in the level. So since this is inherited from this, BP rchar will have all the properties of ACPP rchar. Similarly, you do that for all the other classes, and that's how you'd work hand in hand with Blueprint and C++. Blueprint is going to make your coding a lot easier. So it's basically your visual scripting language. So it's going to be very simple to write game logic. But when it comes to finer control and when it comes to using other libraries, when it comes to doing mission critical stuff, you would use C++. So that's basically how you use Blueprint and C++ hand in hand. Of course, this is a very in-depth topic and we are going to be talking about this in the future. Now let's actually go ahead and work a little bit more on whatever we learned till now. So now that we know about the basic inheritance hierarchy, let's actually start creating stuff on our own. Now, the first thing which you might want to create are variables. Now, for our case, just for reference, we'll be using our CPP object.h. But anyways, you don't have to use this. You can do this inside the actor as well. So stuff like that will remain the same. Most of the time you will not have anything in the global scope. You will create everything inside of your class itself. So the rest of your file, maybe if you are creating a new struct or something, you'd use it, but most of the times you will be doing stuff inside the class. So let's create a variable. Now you could do your normal C++ syntax thing. So for example, let me just create an integer. So by using int, let's say our integer variable. Alright, you could initialize it here or in the constructor. Now, one thing that you might know is that since this is private, are derived classes. Hence, any blueprint class which we create out of this cannot access a variable. So, in order to actually access it, there are two ways. I'll be showing you guys both the ways. So, I'll type in our private integer variable because we made it private. This is how you would ideally do it. I'm just explaining you guys each thing, but you could brush through if you are already aware of object-oriented programming. But anyways, it will give you a learning experience nonetheless. Now, another way you could do it is you could create a variable in the public section. So we'll call this one our public integer variable. Now this is good if you want to access it everywhere. However, it's really not appropriate to do it this way, because if you have it in public, any other class can just straight up modify this variable, which is not good for us. Let's say you have something like your character speed or something. It's very easy to misinterpret that, maybe accidentally change the value, so it's better to have getters and setters instead. Now this is how you would work with a public variable. I know you guys are still waiting for the Unreal's reflection system. So all these macros which you see, U class, U struct, U property, I'll tell you about all those. Not to worry. Now another thing is that since this is private, in order for other classes to access it, we actually need to define a method. So we can call this one int get our private int. We called it integer over there, so let's call it like this. Now we also probably need a setter, so set our private integer. Now we don't have a function definition, so the reason I told you guys at the beginning that you don't really need to know too much C++ is that once you know how to write the declaration, you could just right click quick actions and you could just create a definition like this. Same way with our setter function. Oh, and this has to be void because we aren't actually returning anything. You could make it bool. So let's say you have a condition where you can't set it. So let's say for a health variable you can't set it to 101. So then you would do those checkings and stuff. But in our case we'll just use void. Head into the file here. And instead of this, we will return this variable. So not public, we'll return our private integer variable. Now this is how you would set it up for the private variable, and this is the proper way to do it. Also, uh, currently none of these use Unreal's reflection system. Now if I just run a debugger, so it's going to launch the editor. Make sure it's set to development editor in the configuration. So wait for that to build. And once it's done building, it should start the editor. Now, in order to actually use this over here and actually check stuff in Blueprint, so what you would do is you would right click, go to Blueprint class and type in cpp underscore object, but you see that it's not visible. Now, the reason it's not visible, but our actor was visible, because by default all actors, if you were to go into this file, by default all actors are going to be marked as blueprintable. So if I actually head into the actor over here, and if I actually look into this U class macro, you see it says blueprintable. So what we need to do is, in our object, if we want to use this in Blueprint, that is, inside this U class macro, type in blueprintable. Now this is how you expose your U objects to Blueprint. So let's say anything is not accessible in this menu over here under all classes, it probably means you haven't marked it as blueprintable. So let's stop the debugger and run it again. So wait for it to compile. Then once the editor loads up, we should be able to use our cpp underscore object class. So give it a second for it to load. And now if I head back into blueprints, right click, blueprint class, cpp underscore object, you see that it's usable. And this one will call it bp underscore object. Now, if I just right click and if I want to access the function, so we have get our private integer. So get r, and as you can see, there is really nothing. The reason is Unreal doesn't really know that you want this to come in the editor. Basically, you're not utilizing the Unreal standard macros which enable you to do it. So how you do it is, for variables, what you do for a public variable here, we are going to type in uProperty, and in the arguments we'll use a parameter known as blueprint read write. Now when you put this in the arguments, basically what you're saying is you want this to be readable and writable in Blueprint. Let's say you only wanted to be able to read it, you do blueprint read only. Now how do I know how to do this? Basically you can just head into your browser and type in uProperty UE4 or UE5. Oops, not properties. So yep, uProperty. So basically you have to go to the documentation page, and as you can see, there should be a list of specifiers somewhere over here. There is. So all of these are the specifiers. So let's say you wanted a function to be blueprint callable, you do that. There is blueprint pure as well. I'll be showing you guys the common ones, but you can have a look at all of these. The documentation is king. Now for a private variable, actually we don't need to make this a uProperty. However, you could choose to make it. Now if you want to use these getters and setters, which will technically enable us to use our private variable, our get function will be pure, of course. So we are going to use a u function now. Now u function is another macro. Again, you could have a look at it. So here, if I head into u function over here, you see again there is documentation which talks in depth about this. We will be looking at the common ones anyways. This one will be blueprint pure. Blueprint pure means those green nodes which we saw without any execution pins. So if I actually head into any blueprint, these types of nodes basically without this execution pin, that's going to be our pure function. And I talked a lot in depth about it when I talked about blueprints and stuff. Now this one will be a u function as well, and this one will just be blueprint callable. Alright, Now we can go ahead and run a debugger. Now we should be able to access these. Now live coding is a bit finicky. That's the reason I'm not using it. Otherwise I would have chose to use it. Now let me just create that. I didn't actually save it. So cpp underscore object. We'll call this one bp underscore object. Save that this time. If I open it up now and if I type in get our private integer, you see we get this function which gives us access to the value. Similarly, set our private integer also works, but it's kinda useless. We actually didn't set up any functionality. So let's just take in a parameter. Parameters are pretty simple except references. Everything else is going to be the same for parameters, like how you do in standard C++. So you could type in int new value, and over here as well we could just head into the definition and change that, and then we could do our private or our public. It should be, nope, it should be private. So our private integer variable equals new value. Now that should fix things. So we should have our logic corrected over there, but that's not really our concern right now. Now what if you wanted to take a value by reference? Now this is passed by value and it will work. You could try it out. Not really going to waste my time to show it. If you actually want your value to be passed by reference, you use this macro known as uparam. So uparam ref, and then you use an ampersand over here. So copy this, do the same thing in your CPP, and now if I go ahead and actually build this once again, and in my object, if I go ahead and type set our private integer, you see it's taking in by reference. If you hover over it, it says new value integer by reference. So this is how you do pass by reference. I just showed that. This is one thing which is a little different from C++. You can't just use an ampersand. However, if you use an ampersand, it is going to take it as a second return value in Blueprint, basically like your out parameters. So let me show you guys what I mean by that. So if I do this, now this is wrong. Logically, this is wrong. I know that. But anyways, I'm just showing you guys what's going to happen. So if I go ahead and run a debugger once again, this time it's going to take it as an output rather than an input. If I open my BP object again, and if I type in, let's say, set our private integer, you see the new value goes out. Basically, this is how you handle multiple return values as well. You could just do pass by reference, and in Blueprint, it's going to interpret it as an out parameter. In our case, uparam ref was the correct choice, so we are going to do that. Undo this over here as well. So that's about it. Oops, just correct that. Also, if you guys want to access your public variable, you can just directly use our public variable. So our public integer variable, so it's directly accessible to us. But one thing you might notice is that unlike these variables here, it does not let you edit the default value and stuff. Now, there is one reason for that. That's because you again need to set a flag in order to do it. Remember the uProperty macro? Over here you have to type in edit anywhere in order to be able to do it. So edit anywhere, if I can spell that correctly. If I actually do this and run a debugger once again, I should be able to use our public integer variable and set its default value. Now if you were to see under the class defaults, we have an option to set the default value, or when we even get our public integer variable, you see that we can set our default value. So this is basically how you expose that to Blueprint. I suggest that you guys now try it with a few more functions of yourself, and maybe check how they work in the editor and stuff. Once that's done, let's talk about the next type, that is uStruct. So basically, if you want to create structs for the Unreal Engine, you need to use the macro known as useStruct. Now, generally, I prefer doing it inside this .h file for your project. So you will have a file like this, but you really don't need to. You could do it in any file. So for example, let me just do it in our cpp object.h file. It could be really anywhere. Unreal is going to recognize it for you. So I'll just do it above our u class. So I'll just type in struct. And if you guys don't know what struct is, well, you got to learn that before. It's basically like a class, but by default, all its members are public. But remember, when you're working with Unreal Engine, you don't really work with struct methods. You only work with variables, and any methods you'll have it in another class as static functions. So that's how you work with it. Anyways, I will show you guys what I mean by that real soon. So for example, let's just create a struct known as, let's say, book. This is obviously highly impractical, but just as a basic example. And for the variables, we could have maybe a string. Now remember, in Unreal Engine, the variable you use is not std string. So you don't use std string actually. What you use is called fstring, which is Unreal's string type. Obviously, most of the string types are just interconvertible at any point of time. So if you're using a third-party library or something, you can convert it. So fstring is the string type in Unreal. So if I type in fstring, let's say name, and maybe we can have an integer for number of pages, and we can have a float for rating. Alright, we have a really basic struct over here. Now if I go ahead and build this actually, so I'll close my editor. If I go ahead and build this, you would see that it would build successfully. However, obviously, as you would expect, you cannot access this struct in the editor because we haven't used the Unreal macros. So in order to use this in the editor, you call useStruct. And inside the parameters, what you do is you would make this blueprint type. So this is what you use to expose struct to blueprints. Now if I actually run a debugger right here, so you would find that there are a few build errors. So what this is this is not your C++ compiler error. Basically, there are a few rules in order to use structs in Unreal. Similar to how you have a U prefix, for all structs you need to have an F prefix. So now if I go ahead and run this, in the editor it's going to be visible as book. You see that we get another error. Now it says expected a generated body. Now if you notice our class here, it has a generated body. Similarly, for our struct as well, for all useStructs, we are supposed to be having a generated useStruct body. So it's going to set stuff up for the editor for us basically. So now if I go ahead and build this, you should see that we compile successfully. And we open up the editor right now. But you will soon notice one problem again, which you probably would have guessed if you would have seen these. So if I just head into my object, for example, and if I type in, let's say I create a new variable and call this one book1, and I get the type book, you see I can access this. There's no issue. But if I right click, I can't actually split the struct pins. Now if you actually hover over this, cannot split the struct pin, it may be missing blueprint exposed properties. So what it basically tells us is we actually need to mark these as U property as well. So the same macro can be used here as well. So U property, and there's a little bit of an issue with the indentation there, don't mind. So U property again make this one a U property. Depending on what you want. Let's say we don't want to be able to change the name, so let's make that blueprint read only, so then we won't be able to change it. Now if I stop debugging and open the editor once again, Now if I go ahead and take a look, and if I drag this in, right click and split struct pin, I am able to split it. Now if you drag this in and if you want to edit the members, you'd use the set members function. And obviously you can have number of pages and rating as a parameter, and we set name as not being editable since we did blueprint read only. As you can see, we don't have that available as a pin. So this is basically how you use structs in C++. Now the way you use it in C++ is pretty much the same like how you would. By the way, if you want struct methods, you can use them, but you cannot write U functions inside struct. That's the thing. So if I actually go ahead and try it, basically, I'll show it to you guys. So if I head in here, type in, let's say, void test function, and I'll just give it a simple body here, and I won't do anything. Now you would see that it will build successfully. There won't be any issues. So as you can see, it builds. But if I actually make this a U function, I won't even give any parameters. If I just make this a U function, as you would see, it says U structs cannot contain U functions. So how do you actually do stuff with it? So how do you actually operate on structs? Basically, what you would do is instead of having the U function here, you would have it inside either a function library class, or you would have it inside some other object and make it a static function maybe. So let me actually show that. So let's create a test function. So for example, let's create a U function here. So U function, and what we can do is we can make this blueprint callable. And over here, instead of just declaring a regular function, let's do a static function, static void test. And now we want to operate on this struct. So if you want to operate it similar to your objects, what you could do is you could simply create your own target pin. So the way you do it is fbook target, and obviously you would make that a reference. So U param, and in the brackets you would have ref. So you would pass this as a reference, and then you could work with it inside. So I can write the definition here as well, but just to be a bit cleaner. So quick actions. So whoops, quick actions, and I can create the definition. And now that we've actually come this far, I'll just show you guys how to print strings. So it's not like blueprint where you directly just call, print string, and this is not gonna work. So I can't just do this. So let's just say test function called, for example. I actually cannot do this. The very simple reason being that in Blueprint, Unreal actually imports, or rather includes, all your headers for you as per necessity. But basically that doesn't happen here. So it's not exactly headers, but you get the point. So in order to use print string, so how you would go about searching for functions is you do something like this. So you do print string Unreal C++. This is how you just search it up, and you would look for the one which says docs.unrealengine.com, and you would head in here, and it tells you the include file. So copy this path, paste this in, not path, rather the include, and now you would see you have all the various parameters, some of which are optional. There are only 2 parameters which you actually need, but anyways, now what we can do is, now you notice that you're not able to call it, but that's because this is actually a static function once again. So what you do is you do ukismet system library, and followed by scope resolution, print string, and now you'd see that it still shows an error. That's because you actually need to pass in a world context object, because it doesn't really know, where to output the string, like how to show it on the screen. So in order for it to know that, you actually need to pass in an object. if this wasn't a static function, you would just use this. So if this were inside an actor and it's not static, you would use this, but it says this may only be used inside a non-static member function. So what we can do is we can just pass in a uObject pointer over here, or rather we'll just pass in an actor pointer. So a actor pointer. Now remember, when you work in C++, any object, any actor, anything that you have which is enclosed in a class, basically any class, if you want to use them, you would use a pointer to it. You will never refer to it as a actor. It will always be a pointer. Just remember that. So an actor is just to give, some context to it. So we can just type in context, for example. It could be an object as well, I assume. So if I type in context here, now we would see that the error is gone. But obviously we changed the function signature. You could make this a uObject pointer, I believe. And now what we can do is we can copy this over, head back into our function declaration and put that in. So now our error should go. Now if I go ahead and actually run this, now if I head in to blueprints and BP object, or here if I call test, for example, I think it's called test. As you can see, now we can operate on this struct, and for the context what we can do is simply we can plug any outer object in. So I'll just actually do that. So I'll open up the level blueprint. So for the context, what we can do is we can go ahead and get a reference to self. And for the target, what we would do is we would go ahead and actually get a struct. So instead of this, I'll just create a struct. So I'll just call this struct, for example, and it's going to be of type book. So we can use that, and now this function is going to operate on this struct. So this is just a basic way you can do it. Now if I go ahead and press play, after 3 seconds you should see something being printed, test function called. As you can see, that works. So that's pretty much how we would handle struct methods. So that pretty much covers the basics of using structs in Unreal C++. Now the next thing is obviously enumerations, and that should be about it, and then we can start working with a little more complicated things. At the base level, enumerations in Blueprint and C++ work the same, but in order to create them in C++, you can do the same thing actually. You can do enum. This one doesn't really need to have a prefix, by the way. So for example, let's just say fruit list, let's just call it. And inside that we can have our list items. So let's say we have apple, let's say we have our mango, and let's say we have a banana. Stuff like that. Make sure you just end everything with a comma. Now again, the same thing. This is not exactly exposed to Blueprint, but in order to actually expose this, you use the same specifier as your uStruct, but instead you type in uenum. If you use the uenum macro and if you add in the parameter blueprint type, now this would be usable in Blueprint. But if you wanted to give it a different, name for it in Blueprint, so if you wanted to give a display name to this, basically, what you'd do is you'd use another macro known as umeta, and over here you'd change display name equals and you'd put in the string. So in our case, let's just call this one apple underscore 1 maybe. So just for me to demonstrate that it works. Now if I actually run the editor, and I can just go ahead into any blueprint and I can operate on that. So I can say switch on whatever we call that fruit list. As you can see, instead of apple, it actually shows apple 1, and mango and banana is just shown as is. Generally, what you would do is you would simply have the display name to just display exactly what this list item was. So you would simply have this, and you would have mango over here. Generally, you would just leave it like this, banana. So this is how you would go about doing it. Now we have brushed through the basics of Unreal Engine C++. Of course, if you want to know what function calls to use for your gameplay specific needs, you could refer the documentation. And later on when we actually take an example, we will look into some of the common ones. So it's not really that you have to refer the docs for everything. I will be going through many of them. Now over here, let's actually do a quick exercise. Let's try to translate this into C++. Now, if you were to notice, this entire thing is actually purely in Blueprint, and let's say we wanted our code to run faster, or for whatever reason we needed it to be in C++. So let's actually go ahead and translate that. So it's really simple. Let's start step by step. So we have our get player camera manager function. Let's see which header file we need. So it says target is gameplay statics, right? So this tells us that we need gameplay statics. So if I head into Chrome and if I type in gameplay statics UE4 or UE5, you see you actually get the documentation page. So over here we can get access to which header file we need. So Kismet gameplay statics.h. So stuff like that. Let's actually go about doing it. Now for the cast node, we need a C++ class because all our C++ classes will not have access to the blueprint classes, but all our blueprint classes will have access to the C++ ones. So you cannot access a blueprint class from C++. So that's one disadvantage. Now let's go about doing this. So I'm just showing you guys one example. Obviously, we will talk about a few of the common ones such as spawning actors and stuff, which are really common. Now, let's start in the editor. So let's go ahead and actually create the classes that we need. So first of all, we need a base class for our BP character. So go ahead into tools, new C++ class, character, and call this one CPP underscore character. Of course, you can name it descriptively if you wanted. Create the class, head back in, and we need a couple more things actually. So one thing that we need is the pickup class itself. So type in actor and call this one CPP pickup. Alright, create the class. Now what I want you guys to do is head into BP pickup, and over here under class settings for the parent class, I want you guys to select CPP pickup, and over here as well I want you guys to select CPP character. So CPP underscore character, I want you guys to select that. Now what this basically means is that you are inheriting this BP character class from CPP character. So everything that's there in CPP character will also be there in BP character. Basically this is your inheritance. Now let's head back in. Let's just reload this, and I think we can close the editor for now. Or actually we might need that for reference. So let's actually open up the character. So we need a player camera manager, and from our header file, from our documentation, we know that we need this header file. So inside our character.h, because that's where we wrote it, always when you're including header files, you need to do it above the generated.h. So over here, Kismet gameplay statics.h, and let's just do this in the public section, and let's have a look. So when we press our left mouse button, we get the player camera manager. So let's try calling that static function. So go ahead. Let's actually create the function. Let's call this one, I don't know, what do we call this? So we're just tracing and destroying. So let's call this one remove pickup or something. So void remove pickup. Alright, we don't really require any parameters. Now let's go ahead and create a definition for it. So, whoops, let's just head in. and it has created the definition for us. So let's go ahead and get that. That's a static function. So u gameplay statics get player camera manager, and over here what we can do is for the world context object, since this is an actor, characters are actors, so you can just use this. Generally you would just use this, and player index is 0 since we have only one controller per screen. So we got the camera manager, and from this we need the actor location as well as the forward vector. So what we do is, let's actually just store it in a temporary variable. So we can type auto temp equals, and we can store this in a variable. And what we can do is we can go ahead and get the actor location. So this is a pointer again. So temp with the pointer operator, we can get the actor location. We have forward vector here, let's do that as well. And temp get actor location. Now this might actually warn us right now to use the get camera location function. So as you can see, use get camera location instead. So get camera location, just spell that correctly. And now we have access to these locations. And what we are doing is we are basically plugging this into the line trace. So what we can do right now over here to simplify things is we have a forward vector. We grab that in and we multiply it by a float. So the operator is already overloaded, so we multiply that by 50,000 in our case. So let's just do that. And if we head back into our blueprint, so we add that to our camera location. So plus our camera location, so you could just do a plus again. So plus our camera location, we can put these in parentheses just to be a little more clear on what we're actually doing. So we can delete this line. We have that. Next, what do we have is our line trace. So if you just hover over this, you see it says target is Kismet system library, and I know this header file, so I'll just do it for you guys. Anyways, what we are doing is going to be correct. So let's close this up. So it's going to be Kismet system library. You could have a look at the documentation as well. So Kismet system library. And if we include that, our error should go. And if I open up the CPP file once again, now we should be able to call the line trace function. So u Kismet system library line trace. If I do that, I should find line trace single. And for the parameters, we have a bunch of them. So first one is the world context object, which is going to be this again. And next we have the start and the end location. We look into all of that. So this, and our start location is going to be our camera location. So what we can do is we can actually store this in a variable right now. So what we can do is we can type in auto camera location equals get camera location. Now for the start, we can go ahead and type in camera location, and then we have our end. So again, we can store this in another variable. So auto end location, or let's just call this one end, equals whatever calculation we just did right there. So end is what we called it. Then the next parameter we have is a trace type query, which is the trace channel. So this is what you see over here. Now over here, this is a little bit peculiar in C++. So if I just do eTrace type query, so eTrace type query, and if I take a look, you get something like 1, 2, 3, so on. Basically, these are what you define in the project settings. So if I actually head into my project settings and just type in trace, you'd be able to see that you get trace channels. By default, we actually get two, that is visibility and camera. So if we just do trace type query 1, that is going to be your visibility. And then if we take a look, we have a boolean for trace complex. We don't really want to trace for complex collisions here, so let's just do 0, or that is false. And over here we have a parameter which we actually don't need, and we also have a few more, I guess. We'll just use the ones which we absolutely need. So actors to ignore, we can just create an empty array and we can just pass that in. So t array a actor pointer, and I will get to TRAs, don't worry. Basically, this is like your std vector in standard C++. Instead of that, the one used in Unreal is called TRA. So all the same functions exist inside this as well. Instead of dot size, you have, dot num. There are a few names which have changed, but this is pretty much like your std vector. And let's just call this one ignore, and we'll just pass that in. So ignore. And the next parameter is draw debug trace. So basically whether you want to see the line trace or not. So draw debug trace. Whoops. And over here we have for duration, for 1 frame persistent. Let's keep that for duration for now. Alright. Once that is done, we have our hit result which we are going to output. So we'll just create another variable. So f hit result, and we'll call this one hit or out hit or whatever. And what we can do is we can just pass hit over here. And once we have our hit result, we have be ignore self. Yeah, we want to ignore ourself and don't really need the trace color because this has a default value. So that's about it basically. So we can go ahead and close this. So I feel these parameters should be enough. And once this function is completed, we should have access to everything that we can possibly think of. So the first thing that we are going to do is we are going to cast it to the pickup. Now, in order for us to work with this, first of all, we need to include the header file. So hash include, because we don't know what cpp pickup is. So we'll just do cpp pickup.h. So this should compile because it is in the same folder. And once we actually include the file, what we can do is we can simply cast it. Now you won't use a dynamic cast here. Unreal actually has some things built in for us. So we can get our hit. So if hit dot actor dot get actor, if this is valid. Now at this point, if we haven't actually hit any actor with our line trace, basically this if is going to be false and we are not going to execute this code. However, if we have hit the actor, we can go ahead and cast it to our pickup. So if can go ahead and cast it. So this is going to be a cpp pickup. This is how you cast in Unreal C++ basically. You have a cast function, and over here we can just pass in the actor. So if this actor is valid, so again the pointer is going to be pointing to an actor if it is actually valid. In that case, what we can do is we can go ahead and destroy this actor. So hit.getActor, and we can call the destroy function. That's about it. And just to make sure, what we can do is we can just print it. So ukismet system library print string, and over here we can just pass in this instead for the world context object, and we can print destroyed a pickup, and we can go ahead and terminate that. So now in order for us to actually be able to call this from Blueprint, we'll set up input and stuff a bit later in Blueprint. It has a couple of extra steps. So in order to expose this to Blueprint, we'll again use a u function and make this one Blueprint callable. Make sure I get the case right and just indent that. And now if I go ahead and close my editor and run a debugger now, the editor should load up, and if we open up our character, we can get rid of all this code, and I don't know what we call this. So we called it remove pickup. I don't even know why we called this, but we can call remove pickup. Remove pickup. Now if I go ahead and press play, and if I left click, as you can see, our logic actually works. And okay, this is not a pickup, this was just a cube, so that's the reason it didn't work. But anyways, the line trace works. Now the reason it's working is because BP pickup is also a CPP pickup because we inherited from it. So that's the reason what's happening is when we actually cast it over here, we are actually successfully casting to our CPP pickup as well, even though that was a BP pickup. So that's basically how we translate it. Now we can go ahead and clear out some stuff. This was just for clarity. So instead of using the camera location as a separate variable, we can go ahead and copy this over. Similarly for end, we could just do the same. And if we have anything else, we could do that as well. So we don't have anything else. We can go ahead and close this up. We'll leave this temp variable because having such a long line everywhere is going to be a little bit weird. But again, you could do this. So you could just place this instead of temp. Wherever temp is going to be there, you could go ahead and get the player camera manager and do that. But in this case, actually using temp would be a better solution. So we'll just stick with using temp. So we have brushed through quite a bit regarding C++, and as we create stuff, we will go through more things. Now, what if apart from a pickup, we also needed to cast to some other thing? So let's actually create another actor. So let's do it with our interaction actor itself. So let's go ahead and open it up. Not sure where we've used it. So let's just hit Ctrl F to find, and let's just find interaction. So we are basically nudging it. So what we're basically doing is we are again casting. So I have to just check where it is. So if we are overlapping, so that's what we are doing. So let's actually remove this logic and let's actually have the destroy logic itself. So remove this and remove this, or actually we could keep this. Now if you wanted to do it with your cast, so what you would have to do is you have to cast to interaction actor. If this fails, and then destroy it, and this for the most part will work. So let me just go ahead and drag that in. Forget about the C++ logic, and as you can see, this works and even this works. However, one thing you might notice is, let's say in an actual game, obviously we'll have many such actors, not just an interaction and a pickup actor. So in that case, you will have to perform many casts, and casting is expensive for your computer's performance. So the way you get around this is, instead of casting multiple times, you could cast to an interface. And in Unreal Blueprint, there's actually a very elegant system implemented. We'll be talking about both the Blueprint and C++ versions of interfaces now. So in order to handle this problem, what we can do is we can actually create an interface. So I'll show you guys step by step to implement this exact logic using an interface. And we can actually have separate logic as well for both the interaction and the pickup actor. So head into your blueprints, right click, blueprints, blueprint interface, and let's just call this one, I don't know, destruct, I guess. Generally I have a convention of calling it BPI underscore. And we can call this one destruct pickup maybe. Alright. And we don't need anything for the input. But anyways, now the way you actually use this is for whichever actor that needs to be casted to. So for example, we are casting to our pickup and our interaction actor. So we would head into both of these, and under your class settings, under implemented interfaces, we can go ahead and implement BPI destruct. And do the same thing for the interaction actor. Head into class settings, BPI destruct. Basically, at at the fundamental level, what this is doing is it is inheriting this interface along with actor. So basically your interface is also a class internally in C++. I will show you guys the C++ plus version, which will make things a little more clear. But instead of doing all this, what we can do is we can call destruct. Or I guess I called it pickup. So let's just call it destruct in general. To compile and save that. So we call this destruct. And now if I actually go ahead and press play, I mean nothing's gonna happen because although we have destruct, as you can see we can't really define the logic here. The way you define the logic is, for example, we can head into pickup, under interfaces, right click, implement event, and if I go ahead and just print a string and I can type in destructing pickup, and if I go ahead and destroy it, so destroy actor and target will be self, and I'll do the same for the interaction actor. So implement this event, whoops, paste this in, and we can do destructing whatever this is, interaction actor. So now you should be able to see that both of these different implementations are actually called. So if I press play, you see our pickup is destroyed, and if I actually click on this side, our interaction actor is also destroyed. So this is how you basically use interfaces instead of casting. Basically what it's doing internally, even though this looks like we got rid of casting, is instead of casting to our interaction actor, it casts to the interface, because interaction actor implements that interface, the cast is going to succeed and the function will be executed. The situation where the cast fails is automatically handled in the engine. Now how do you do the same exact thing in C++, you may ask? It's pretty simple actually. You just use the concept of multiple inheritance in C++. So tools, create a new C++ class, and over here what you have to do is select Unreal Interface, and we can just call this my interface for example and create the class. It should load up Visual Studio for you. So just reload that, and over here you should be able to see my interface.h and my interface.cpp. Basically this is where you would write the function definitions, and you can go ahead and define it in your various classes. So what you do is, for example, let's just have this function work for both the pickup and our whatever that was, interaction actor. So let's say we want this function to work for both of them. So let's go ahead and do that using an interface. We'll actually get rid of the C++ logic. So we'll get rid of that. And what we got to do is, first of all, since we are actually casting to the interface here, we can go ahead and include the header for that. So hash include over here. We can go, okay, we are including pickup already. So what we can go ahead and do is we can go ahead and include this interface in the pickup. So not after the generated, before the generated.h. And this is going to be my interface.h. And over here where you see public a actor, put in a comma and type in public I my interface. I is basically the prefix which is used for interfaces, just remember that. So my interface in the editor is going to correspond to I my interface in C++. So let's actually write our function. So let's call this void destruct maybe. And we can go ahead and add in our implementations. So we can right click first of all and make this one virtual. Right click, quick actions, create a definition for it. This is just going to be like your default implementation. So now let's say we wanted to implement this function in another class. It's really simple to do it. Now that we have a virtual function here, we can head into our pickup.h, and over here along with this we can type in virtual void, and I don't know what the function was, so I'll just copy this over. Do the same thing in the pickup. And since we are actually overriding a base class method, what we can do is we can use the keyword override. And now if I go ahead and right click quick actions, create a definition, head in here, and now let's say we do the same thing. So let's say we do ukismet system library print string this, and let's just say destroyed pickup from C++. And we need to include Kismet, of course, so let's just do that real quick. So let me just copy this over. So I'll just do this in the .h file. So now we can go ahead and actually destroy it. So we can say this destroy, or rather you can just call destroy. Alright, so we can go ahead and test this logic, but remember it's not going to work for our interaction actor because we again don't have another C++ class for it. So let's actually create that too. So new C++ class actor, let's just call it, for example, I don't know, cpp underscore interaction actor. Okay, so we'll create the class. And what we can do is we can again implement this. So in order to implement the interface, so I'll just stop the editor there. So in order to implement the interface, we'll do the same thing what we did for pickup. So if you head into the header here, copy this over, head into your interaction actor, implement the interface, and again we need the header file. So what we can do is we can do hash include whatever this is. So we have my interface.h, and then we can go ahead and implement this event by using virtual void destruct, which was our function name, and we are overriding a base class method, so override. And now we can go ahead and create the definition for it. And over here we can go ahead and print the string again. We can do that by simply including Kismet again. So let me just copy it over. Oops, I copied that. So head back into your pickup where we had included it, copy that, paste that back in, and let's just copy over the code from our pickup. You can have different code as well. I'm just showing you guys as an example on how to use it. So we'll change what we print. So destroyed interaction actor from CPP, and this should work. Also just head back into your CPP file, your CPP character, and where we cast it to the pickup, what you basically do is instead of casting to the pickup, you cast to the interface, since we inherited the interface. So it's going to be my interface, and make sure you actually include the header file. I've already done that. So somewhere over here we have included pickup.h already, and pickup.h already implements the interface, and we have included the header, so we don't really need it. So we can cast to this interface, and instead of destroying and printing, what we can do is we can utilize this. So we can have this separately. So we'll just do auto temp equals, I'm doing uppercase temp because we've already used lowercase temp here, and temp is going to be valid because the cast has succeeded. So what we can do is we can call destruct from here. Alright, now we can go ahead and run a debugger. Now if I head back into my character, connect this up, hit play, and you should see that we say destroyed pickup from CPP, but the interaction actor doesn't work. That's because we haven't actually set up the parent class over here. So go ahead and change that to CPP underscore interaction actor, and we could rename this as well BP interaction actor. Alright, so if I go ahead and press play, the pickup works. And as you can see, destroyed interaction actor from CPP. So that's pretty much it. That's how you use interfaces. And later on, we will also be seeing more practical examples. This was probably a good one, but still we'll actually implement this in our actual game. Now let's look at another case where you want to call blueprint functions from C++. Now this almost seems impossible because your C++ classes aren't actually aware of what blueprint classes exist, but actually it is. It's really simple too. So what you do, you could use it in any actor, any object, even in the interface if you want, but I'll just show you guys in the character by just printing something. So the way you actually call blueprint from C++ is like this. So you just write a normal function. So let's just call this void test bp func, let's say. And now what you got to do is you have to use the u function macro, and you can make this blueprint callable or not, but the specifier that you need is called blueprint implementable event. So now you can have the function declaration over here. You can actually have parameters too. So we can test that if you want. So int x, let's say. So now if I actually run this, you won't actually get a compiler error because Unreal automatically generates the definition for you and you can define it in blueprint. So if I open up my BP character and under functions, under overrideable, if you just have a look, you will have test BP func, and as you can see, I can actually implement this over here, and we also got our input parameter. So we can just go ahead and print a string. We can either call this through blueprint or we could even call this through C++. Let me show you guys by calling it through C++. So I'll do it on begin play. So what was our function called again? Test BP func. And you would see that this is actually implemented. So let's type in 100 for example, and this will work. And in the meantime, now I would like to show you guys one more thing that you can do. I just wanted to show you guys that yes, you can actually do this. You can actually implement it in blueprint. But there is a possibility that you have some C++ code, but then you also have some blueprint code which you want to be executed. So in that case, what you would do is you would use another type known as blueprint native event. So we'll just copy over this function and let's call this one test bp native func, and let's just have something else. For example, let's say we'll have a float. And for this, actually what you need to do is you need to have another function called the implementation of this function. So that is going to be what you define in C++, and this is going to be your function name in blueprint. So in order to explain what I mean, instead of implementable, type in native. Now if you compile this, you'll actually get an error. So what you're supposed to do is not create a definition. However, you are supposed to create an implementation for this. So the way you do it is you just copy over the signature, and instead of the same function name, you type in underscore implementation. Whoops, implementation. So what you can do now is for the implementation, you can go ahead and create the definition. Head into your definition and we can go ahead and print something. So let's say we go ahead and print, for example, let's just say C++ implementation called, and we can close that in. And for a blueprint implementation, we can set that up in blueprint, no issues. So that should be it. Now you can go ahead and actually compile this once again. So apologies, I just made a few typos over here. So let me just copy implement over here. So implementation, and do the same in the CPP file as well. So underscore implementation, and now you should have no problems. So if we head into a BP character, and we can go ahead and override both of them. So